Hello everyone. This is Uday Yedluri and I'm working in IT over 20 years with cloud architecture, security and performance engineering. In my career, I've had opportunity to help enterprises navigate the challenges of multi-cloud environments from avoiding vendor lock-in and ensuring compliance and by squeezing last bit of performance out of every penny we spent and every infrastructure we stood up there. I worked across AWS, Azure, GCP, and very extensively on the on-prem cloud environments. So I've seen firsthand how to manage multiple clouds, bring enormous flexibility, but also a fair share of headaches comes with it, right? Like performance bottlenecks, increased attack surfaces, and operational complexity often comes becomes a biggest roadblock for this any kind of innovation, right? So that's why, like today, I want to share how Rust, a language built for safety, speed, and reliability, is changing the game. And we'll look into how organizations are using Rust to build high performance secure tools that run consistently across heterogeneous environments, and why the modern enterprise, like multi cloud, is no longer an optional thing, it's a strategic imperative. So let's talk about why Rust actually, why I choose Rust over any other, and why I want bring more attention to the Rust, right? Rust is like modern programming languages, which is designed for speed, safety, and reliability, especially in systems where performance is critical. And it runs nearly as fast as C, but without any memory risks of C. That's one big thing. And it is safe, actually. One of the very safe product where it prevents common bugs like memory leaks. That's one big thing with C, and crashes and data races, right? It's very reliable, encourages clear, maintainable code that works consistently across the environment. It's popular in industries where security and performance matters most, like finance, cloud computing, and embedded systems. Companies use multi-cloud providers to avoid lock-in, cut cost, and to ensure compliance and improve resilience. But it's not easy, right? Security risks and management complexity grow without good tools. Also, think of it like managing multiple houses. So if you have a house and you have a second house, a third house, and first house is fine, a vacation house is okay, and having a third, fourth house, then the problem starts coming into the picture, right? So similar like multi-cloud, right? Once one cloud, easy to manage, piece of cake. Two clouds, maybe it's okay. Or hybrid architecture where on-prem cloud, maybe it's okay. But once you expand beyond, it's not easy, and it comes with its operational challenges, technological how much people need to know about each product. The ops is like biggest challenge for enterprise teams. So why Rust is an why Rust for a multi-cloud excellence, right? Performance, security, and developer experience, right? These are the three main things, and it is very ideal for building tools like work reliability across AWS, Azure, GCP, etc. So it's very fast, very smaller in terms of footprint, and more predictable apps, and also catches memory bugs even before the code even runs. Great tooling and cross-platform support. So those are the main things about Rust. So what why Rust multi-cloud impact areas, right? What are the Rust multi-cloud impact areas? So it's performance, container orchestration excellence. That's one thing. Like container starts faster and use less memory and when written in the Rust. No delay from garbage collection like some of the other languages. Some files, quicker deployment and cheaper storage. A big bank saw like almost, I'll say, 30% to 40% save in latency by choosing critical components to Rust, actually switching critical components to Rust. And infrastructure as a code revolution, we all know that this revolution of infrastructure as a code. So almost like two third of companies are like are trying Rust-based tools for cloud setups. Very fewer mistakes thanks to Rust strict checks and the preventive other checks or forms and faster provisioning over 3 to 4 times quicker than the old ways of doing the business deployments. Works like seamlessly across different providers without any surprises. Great advantage of being with this tool. Resilience, multi-cloud, and microservices. So the Rust prevents problems in the system that run across different clouds at the same time. It forces you to handle errors properly. Result apps that recover quickly from failures and keep running smoothly. That's a big that's a big thing actually. And coming to the security, the multi-cloud means like more places to attack. Rust helps close the doors, prevents the type of bugs that cause more severe cloud security problems. It has a stronger protection against bad dependencies and accidental secret leaks. And case studies and global financial institute, as I said, global financial institute almost saves like a hefty amount of latency issues were addressed, and it is like excellent product, right? It's a great product for healthcare, manufacturing, for data, for healthcare like data processing or HIPAA compliance or any other cost saving mechanisms they want to put in place. Like it's a great tool for them. And also manufacturing like for better quality control, smaller updates for devices, and smoother cross cloud operations. And also coming to container orchestration and excellence. So container ecosystem from the backbone of modern cloud applications, but traditional runtime faces performance limitations like Rust advantages. So it's way 40% faster than traditional builds and no memory overhead. It's almost reduces almost 60 to 70% of memory overhead. And it's very predictable latency without GC pauses during the critical operations, smaller binary sizes leading to the faster deployment and reduction of storage cost, and fine-grained resource control for better multi-tenant isolation. So this is like some of the components I'd like to highlight when coming on container orchestration excellence. And also infrastructure as a code revolution is, we already spoke about this in the previous slide, where it brings almost like two-third of companies trying Rust. And also multi-cloud microservices, like Rust prevents problems in systems that runs different clouds at the same time, forces you to handle errors properly, and results apps that recover quickly from the failures and keep running them smoothly. So ownership model benefits like prevent data races in concurrent operations, guarantee resource cleanup even during the failures, and enforce proper error handling and throughout the code bases. It makes also distributed system boundaryless explicit. And error handling excellence is like another great tool where results type forces explicit error handling and pattern matching for comprehensive error cases, error propagation with the operator, custom error types for the domain specific handling. So let's talk about the security. This is one big thing with multi-cloud. We briefly touched it a couple times already. Multi-cloud breaches are like very expensive on an average, and the single cloud instance due to increased complexity and large attack surfaces. And memory safety critical, like 70% of high severe CVEs are cloud infrastructure components from memory safety issues, precisely what Rust prevents by design. And supply chain protection, like Rust ecosystem offer strong dependency verification and reproduction builds, reducing the supply chain risk across cloud boundaries. And also secret management, right? That's one big thing again. Rust compliance time guarantees helps prevent accidental secrets exposure between cloud environments. And it is a very common source of breaches, right? We all know that. So in this case study of a global financial institute, it's one of the bank that replaced Java services with Rust and which runs faster, cost less, and it was way faster and safer. It got higher uptime and smaller deployment times, and no serious security issues for months after launch. That's one. And coming to healthcare and manufacturing, they have faster data processing, HIPAA compliance, and cost savings, millions of cost savings. And also coming to the manufacturing, like they have better quality control, smaller updates of our devices, and smoother cross cloud operations. Emerging trends in the Rust plus multi cloud. Rust becoming go-to language for secure cloud services, and it's leading in WebAssembly apps that run the same on any cloud. And it's great for edge computing, instant setup, and reliable performance. And let's talk about implementation roadmap and key takeaways on this slide. And it starts small with non-critical services, low-hanging fruits. Start something small and target pain points like performance bottlenecks, which applications has the highest pain points and but still has a very low hanging fruit. Pick something like that and try to address those pain points starting there. And build a reusable libraries for all the clouds so that way it's easy and faster for our further deployments. Measure improvements from day one what you did, and as you days progress keep measuring the improvements, and so that you can optimize better as even things progress. And scale successful patterns, and Rust helps you keep performance, security, and reliability consistent in complex cloud setups. So yeah, scale success is pretty critical actually. So expand successful patterns across organizations with reusable components like and internal advocacy. So these are few things I would like to bring on to your audience. And thank you very much for this opportunity and listening to me all this time. Thank you. I appreciate everyone's effort here. And thank you.